Why does the sky fill with dark storm clouds? Why does rain fall? And why does it snow? Why is the weather warm some places? And why is it cold in other places? What makes the wind blow? Why is the weather always changing?
To help answer our questions, we need to know something about the elements that make weather. By using a drawing, we can show that weather is a mixture of three things.
Heat from the sun. The air that surrounds the earth. And water. Each of these elements plays an important part in making all kinds of weather. First, let's talk about heat. The sun radiates a continuous flow of energy. About half of this solar energy is absorbed by the Earth's surface and changed to heat. Although the sun provides a constant supply of energy, the Earth cannot absorb the same amount every day or everywhere. The amount of energy reaching the Earth varies with the seasons of the year. During the long summer days, the sun is high overhead and shines straight down. The Earth absorbs a lot of energy and becomes very warm. But during the short winter days, the Earth does not absorb as much energy. The sun is low on the horizon, and the sun's rays are spread over a greater area. The Earth's surface is not all the same color. Some areas are dark and some are light. This affects the amount of energy absorbed from the sun. Dark areas absorb more energy and are warmer. Light areas reflect part of the solar energy and stay cooler. Land and water surfaces heat differently. A cross-section of the Earth's surface shows that sun rays do not penetrate very far into the soil, and only the surface becomes hot. But sun rays penetrate water, and by mixing, spread the heat through a large amount of water. For this reason, on a summer day, water surfaces are much cooler than land surfaces. But at night, the land cools quickly, while water releases its heat slowly. Now, the land is cooler than the water.
This uneven heating of the Earth's surface is an important part of weather. It not only helps determine how warm we are from day to day, but it also affects the temperature and motion of the air.
We can think of air as a great ocean of invisible gas covering the Earth's surface. The air is heated by contact with the Earth. Air over warm areas expands and rises. Cool air stays close to the ground and moves in to replace the rising warm air. We call this moving air wind. The wind blows because of the uneven heating of the Earth's surface. Cool air, moving to replace rising warm air. During the day, cool air moves in from the ocean to the hot land. The greater the difference in temperature, the faster the air moves. In the same way, worldwide winds are formed as warm air rising from the equator is pushed towards the poles, and cold polar air flows across the Earth's surface towards the equator. But this simple circulation pattern is broken into three zones. Some of the tropical air is pushed down near the surface. Part then flows south and is turned to the west by the rotation of the Earth, forming the trade winds that blow in the tropical regions. The rest pushes northward and is turned to the east by the spinning earth, forming a belt of prevailing westerly winds in the temperate zone. In the third zone, the rotation of the earth turns the cold polar air westward, forming another wind belt that blows in the polar region. These three major wind belts establish a general pattern of weather change for each region. The prevailing westerly winds carry the weather across our country, from west to east. Now, let's add water to the weather. Water is the only element of weather we can actually see. But where does it come from? And why can't we see it all the time? Water is constantly rising into the air as an invisible vapor. It escapes from bodies of water, moist land surfaces, and all living things. The warmer the air, the more water vapor it holds. If we could magnify water vapor, we would see that it is made up of many tiny particles called molecules. In warm air, the water molecules move rapidly, bouncing away from each other. And the sky looks clear and bright. But when the air cools, the water molecules slow down and join together, forming small droplets of water in the air. Now we can see water in the weather as a misty fog hanging over the ground, or as a cloud floating overhead, made up of millions of tiny water droplets. As the air gets colder, the water droplets continue to grow until the drops become so heavy they fall to the ground as rain. If the air is very cold, the water vapor in the cloud may freeze into snow that floats gently to the earth. Sometimes raindrops are blown up through layers of freezing air and fall back to the ground as hail.
Now that we understand how heat, air, and water working together can make different kinds of weather, we need to know why the weather changes from day to day.
Changes in our weather are caused by moving masses of air that can advance several hundred miles each day, traveling along the weather path established by the westerly winds. When masses of cold air pile up in the polar region, the cold air bulges southward, carrying cooler weather along its path. Masses of warm, moist air form in the tropics and bulge northward, bringing warmer weather. As the two air masses advance and retreat, they bring a changing parade of weather, warmer or colder, wetter or drier. The kind of weather the moving air masses bring depends on the season of the year and the condition of the land. Warm air flowing in over a cold land can form a dense fog close to the ground. When the land surface is warmer than the air mass, warm, moist air rising upward is cooled, and water vapor becomes visible in its many forms, depending on the air temperature and how much water vapor the air is carrying. When an air mass is forced upwards by a mountain range, it is also cooled, and water vapor becomes visible weather. The most exciting weather is caused when air masses collide. As the cold and warm air come together, the warm air is forced upwards and a storm front develops. dramatic headlines tell us of the violent conflict between the air masses. Every day, air masses move across the face of the Earth, constantly changing the mixture of heat, air, and water that makes our weather.